Now source conversions. We're going to perform source conversions, and in doing so look at how we do a voltage source to a current source and a current source to a voltage source. So in doing so, there is a little bit of manipulation that we have to do to make sure that we capture all of the characteristics of the source. So in this case, if we have a voltage source with its internal resistance, we've seen before that all we have to do is add the internal resistance in shunt instead of in series. But notice what we have to do with the source itself. We have to do the manipulation, Ohm's law, V source by R internal in the source to come up with what our current would actually be from that current source. So if we take a look at an example here with a load, so we've got our voltage source with its internal resistance, and we have some load resistor attached to the output, so that we could now calculate what the internal current load is going to be from this practical source, a loaded source. So you'll notice that, just like we've seen before, we have to add the two resistors in series to get the total current divided by the source. Okay, although we know that the current in here through RL will be the same as through RS, we have to calculate by using, in essence, Ohm's law. To calculate for the loaded current source, where we are using the shunt resistor, we now have the same relationship. The current is V source by R internal plus the load, and we calculate the current total then as V source by R internal, okay, because we have the current splitting between these two branches now. So if we take a look, we're going to convert the voltage source to an equivalent current source and show the equivalent circuit. So in this case, we have a 100 volt source and a 47 ohm resistor. So to calculate the current value, again, we have to take V sub S divided by R sub S, and that will give us our current value of 2.13 amps. And then we merely place the resistor in parallel. The source current, I sub S, multiplied by the internal resistance, R sub S, gives us the value of the equivalent voltage source. Now we're going the other way. So V source is equal to I source R internal. Okay, so again, our source or internal remains the same. The polarity of the voltage source is, in this case, plus to minus in the direction of the current. So my drawings here is showing the current flowing out of the source and into the circuit. To convert a current source to an equivalent voltage source, then, in this case where we have I source is equal to 10 milliamps and R internal or R source is 1 k ohm, again, we rely on our mathematical relationships. In this case, it's the product. Let's roll back here. It's the product of I source, R source to give us our value, in this case, of 10 volts. Again, positive, negative, and then the source resistor or the internal resistor remains the same. So we can write the formula for converting a voltage source to a current source as V source by R source, or R internal, will give us the current source in this case. In writing the formula for converting a current source to a voltage source, we have I source as a product with R source or internal, which gives us V source for the circuit. So if we take a look at, again, converting the voltage source to an equivalent current source, in this case, we take the V source by R source, gives us I source, in this case 4.55 amps, and we move the resistor in parallel. To convert the current source to an equivalent voltage source, we use our I source and our internal values. V source is equal to the product, I source, R source, which gives us 110 volts, positive, negative, and the value of the resistor, internal, remains the same. We just move it into series. So now we're going to look at something called the superposition theorem.